Welcome to Discovery School's virtual learning platform.
Okay. Basic 5 pupils. Today we'll be looking at, in our basic technology, we'll be looking at basic electricity. Basic electricity. That's our topic for this class. Now, electricity is something I am very much familiar with. As you know, from your experience, many things that we do is based on electricity. We need electricity to press our clothes. We require electricity to light our house. We require electricity to watch television, to hear radio, and so many other things that we do. We require electricity. So you see that understanding of electricity is very important. And for those of you that might want to pursue a career in electrical engineering, it's even very much important that you know about electricity. Now, what is electricity simply? Electricity simply has to do with charges. Electricity has to do with charges and currents. Deals with charges. Now, there's two types of electricity that we have. Now, the first type of electricity, we call it static electricity, while the other type of electricity, we call it current electricity. Now you see the difference as we go on. Now, as I said earlier, electricity has to do with charges. Now, let me give you some example of charges. One example of a charge is what we call electron. Electron. This is a very popular charge. It's called electron. Now, and another charge, this one is a positive charge, while another charge we call proton. Take note of these two. Electron, proton. This one is positive, that's plus, while this one is negative. The negative charge, this is a positive charge. But let's not dwell on that too much. Now, with static electricity, from this word here, it simply means stationary electricity. When you hear the word static, it talks about being in one place, stationary. Static electricity deals with charges that are not moving. That's what static electricity talks about. And it is generally produced as a result of friction. Static electricity is produced as a result of friction. And as I said earlier, it deals with charges that are not moving, charges at a spot. Now, if for example, you can try it by yourself at home. If for example, you take, let's say, your pen and you rub it on hair, you touch it on the paper, you observe something, that paper will be attracted, like glue to the pen. Why is that? It's as a result of static electricity. There's charge on that pen, and there's a charge on that paper that makes them to come together. Generally, in electricity, this is the simple rule. Different charges, they attract. That is, positive and negative charge will attract. That's the simple rule in electricity. So it simply means for that paper and that biro cover or that biro container to attract, it simply means that there was negative and positive charge on each of them. Now, so that's for static electricity. Now the next one we look at is current electricity. Now current electricity deals with moving charges that are in motion. That's what current electricity deals with. Alright? Charges that are moving, and that's the electricity that you use often in your house. The static electricity, a very good example is lightning. Lightning is as a result of static electricity, but the electricity used for all manner of domestic purposes is current electricity. Electricity that is in motion, that is current electricity. Now next we look at production of electricity. Now there are various means of producing electricity. Now the first means of producing electricity we look at is hydroelectric power. Now what is hydroelectric power? This is the means of producing electricity. Hydroelectric power involves electricity being produced through moving water, like a river. Now what happens in hydroelectric power? Usually what is called a dam. A dam is like a reservoir where water is trapped in. What happens as water flows through the reservoir? The force at which this water flows is used by what we call a turbine. This is the word turbine. That's what the turbine is like a fan. As the water flows, it moves this fan, it starts making the fan to rotate. Now as that fan is rotating, the energy of that fan rotating is transformed, is changed to electric energy that is now transferred to your house to be used as electricity. That's simply hydroelectric power. Now electricity is also produced by a windmill. A windmill is similar to the turbine, but while the turbine requires water to pull it, the windmill requires wind. As wind moves, it turns the windmill, and then that motion is converted to electricity, and then electricity is produced. Now another means by which electricity is produced is from gases or from fuel. Let me use fuel. From fuel, as in a gas station. Now, gases, for example, like natural gas, can be used to produce electricity. As they are burnt, they produce heat that can be converted to electricity. Also, electricity can also be produced in a nuclear can also be produced in nuclear plants, or what we call reactor. So electricity is also produced from hydroelectric power, from a windmill, from fuel as in a gas station. Also it can be produced in a nuclear plant, that's through nuclear energy. So that's for production of electricity. Now next, we look at, last of all, before we conclude this class, at electric circuits. At electric circuits. Now, electric circuits. Now, electric circuit is the part that oh, alright, sorry for that. Electric circuit is the part, when we say part, that is the road, let's use that one, is the part that charges the electric current passes is the part that electric current passes through. Electric circuit is the part that electric current passes through. Now, let's say for example in your house, you have wires, let's call them components of electric circuit, that part of an electric circuit. Now in your house you have wires, also you have yes, switches, and let's take these two important components. Now what happens in your house is this. Okay, let's say an ammeter. An ammeter is a device used to measure current. And then last of all, a light bulb. Now these three at least is something you can easily access in your house. Now in your house, when you press on the switch, what happens is either you are what we say completing a circuit or breaking the circuit. Now let me make you understand. Now in order for electricity to flow, it is important that all these components that I listed here, that they are connected together. Now let's say for example, let's say we have, okay, let me add one part, what we call cell or battery. This is very important because it's the source of electricity. An example of this can even be your generating set. So we have 5 parts of an electric circuit here. Now let me do something like this. You have what we call this A. I will explain what they all mean to you. You have let's say the light bulb here. Okay, and they are all in. Yes, we have a switch. Now this is what we call a diagram of an electric circuit. Now all these things stands for something. Let me put them here. This stands for ammeter. This one here is the bulb, the electric bulb. The light bulb. This is the cell or the battery. That's the source, the generator of electricity. Why this one here? We call it the key or switch. Now, in order for electricity to go around in this circuit, the wire must all be connected. Like for example, you notice here that there is a breakage between these two. Simply means that the wire is not connected here. That means electricity cannot get to the bulb. Why? Because the circuit is not complete. Are you following? Now, so if you complete this circuit, what will happen? This light bulb will on. Why? Because electricity can flow around it. Now all these lines you see here, they are the wires. These are the wires that connect everything. The same thing that happens in your house. When you press the switch in your house, you are either opening it up, that's when the light switches off, or you are either closing it, that's when the light on. That's what happens in your house. So that's what an electric circuit is. A path or the path the electric current passes through. Alright? So next, last of all, before we move on, we'll look at conductors and insulators. Conductors and insulators. That will be the last thing we look at before we call it a day. Conductors and insulators. Now, conductors are materials that allow electricity to pass through them. Those are conductors. Example is metals like iron, copper, aluminium, you know them. Aluminium. Even another example is graphite. So all these things that I mentioned, they are conductors. Now, insulators on the other hand, they do not allow electricity pass through them. So, insulators, they are materials, they do not allow electricity to pass through them. Not allow electricity to pass through them. You can think of some plastics. That's why your wires are covered with things like plastics. Plastics, yes, wood, ceramic. There are many other examples like that, etc. Right? So that's conductors and insulators. So you know these two materials, they are also important because we require insulators, for example, to cover conductors so that they will not shock people, and we require conductors for different processes in electricity. So that's all for our class today. A quick recap on what we did today. We talked about basic electricity and how electricity has to do with charges, that there is static and current electricity, and also we saw different ways of producing electricity, and then we looked at electric circuits, how it is the path through which electric current passes, and we saw different parts of electric circuits: wires, switches, ammeter, light bulb, cell, and then we looked at conductors and insulators lastly. Okay, so I will just leave you with these assignments. Now, number one, what is an electric circuit? And the second one, list the two types of electricity. So have a wonderful day. Good day.
I hope you have learned a lot. You can join us via our website at www.discoveryschoolsng.com. You can visit us at our Agbo campus 11, 21, 23 and 25 Benin Technical College Road, Ugbo, Benin City, and at Upper Mission 268 Upper Mission Road, Benin City. Thank you.